Okay. Hello. Good evening to you all.
Good evening.
Hello. Hello.
Hello, we can hear you.
Yeah, we can hear you. Good evening.
Hello. Please, am I audible?
Yes, you are.
Very audible.
Hello. Please, can you hear me? Hello. Good evening.
Good evening.
Oh, okay.
We can hear you, please.
Oh, all right. Okay. Okay. So, once again, you are welcome for today's training on advanced quantitative techniques in research using SPSS or using IBM SPSS. So that is what we'll be looking at today and that of tomorrow. So today we'll look at certain concepts, and then tomorrow, God willing, we also continue from where we will end for today. I don't know, we are many, but currently it's only 4. That's, let's say 3, including me, that have been able to join. Others are complaining of internet. So I don't know. So we need to proceed. The recordings will be made available to those that are or were unable to join, so that later they can look at it. All right. So we want to begin with what is called the concept of statistical data analysis. In fact, for you to be able to do a very good statistical analysis, or for you to be able to gather data and analyze it effectively, it means that your background in terms of statistics must, one or the other, be strong, so that you'll be able to appreciate the modeling processes. So I outline some basic concepts that you need to follow anytime you want to start modeling. And the first step is to identify the business questions. That is, you try as much as possible to know the domain that you find yourself, know much about it, and that should inform you as to the kind of data that you need to collect and even store. Now, if you belong to the business environment, you need to ask yourself, what kind of question do you want to find solution to? Or what kind of solution do you want from that issue that you want to investigate? So once you know what you are supposed to do, then you need to be able to collect data on that condition or on that problem, and then you keep or store that data set or that data that is available to you. Now, having been able to gather the data using so many approach or techniques, then you need to clean or prepare the data for its intended purpose. Sometimes the data that we gather or the data that we collect are not all that clean, and they are full of noise and even sometimes missing observation within the data set. So what you need to do is, once the data is collected, you need to clean and prepare it for its analysis, or the analysis that you have plan of doing it. Now, after you've prepared the data, or after you've cleaned and prepared the data ready for the modeling process, then you need to analyze the data. So here you need to be able to apply the technique. There are a lot of statistical techniques. There are a lot of tools that we use when it comes to the modeling processes or the analysis processes. You have to decide as to which of these tools that will be appropriate for you to be able to tell the story that you want to tell. So we have from descriptive to that of inferential statistics. So you need to decide as to which of these tools will be useful to tell the story that you want to tell. Now, aside you using the analytical tool, you also have visualization tools that you can use to communicate to the audience or to the people that you want to send the message to or across. So you can decide to use graphs, charts, or any visualization tool of your choice that will be able to communicate to the people of interest. And putting all these things together, we say, or we call it statistics. So if you're able to identify the business question, you collect and store data, you clean and prepare data, you analyze, you visualize, and then communicate the results to the users of the information, then you are talking about what is called statistics. So statistics in brief is a collection of data, organization of data, analysis of data, and interpretation of results to users of such information. I'm very careful here in the sense that you collect data, analyze it, and communicate it to users. So if you're unable to communicate your findings to users or to the people that need your information, that information will not be relevant to society. So that is something that we should know, some basic concepts about statistical data analysis, which we term it as a 5-step framework to analysis or to analyze data. Identify business question, collecting and storing of data, cleaning and preparing data, analyzing and visualization and communication of results to the users. All right, so let's begin with an aspect when it comes to the analysis, because our focus is more on the analysis of the data. This is where our focus is. Analyzing or analysis of the data. So we don't want to go much into the research aspect. So all this side is for research, and then the cleaning is also part of the data processing. The cleaning and the data processing or preparation are all parts of the analysis. So let me skip the first two, identify, collect, and store, because it's more of research aspect, which maybe in appropriate time we will look at the research aspect too. So we are on the descriptive statistics. Descriptive statistics, these are tools that we use to describe the steady variables in brief. They are very, very useful since they give a summary of the variables or the data that we have. And I must say that it is very, very important for any statistical analysis. The researcher should be able to produce descriptive statistics, at least to give an overview of what is happening. I know maybe you want to use regression, you want to use a t-test, you want to use ANOVA or any other statistical tool to analyze your data. But the descriptive statistics helps you to have an overview as to what is happening within the data set. Though they are not statistical in nature, they are unable to give you much information, but at least it gives you a brief and concise view on what is happening within the data set. So they are very, very important. So we have several of them. So you can use the mean, the median, the mode, that is the central tendency. We also have the dispersion, that is the range, the variance, standard deviation. And we also have the shape, that is skewness and kurtosis. And these are very, very important, especially if you want to talk about normality of a data. You'll be using the skewness and then that of kurtosis to do that. So these tools are very, very important. They're descriptive, though they are not statistical in nature, but they are able to give us much information about our study area. So to begin with, the training is more practical than theory. So we are not going to do much of theoretical kind of, let's say, workshop, but rather it's going to be more of practical in nature. So I have sent you data set, series of them, and we'll be using them to do the training. So please, you can open or click on your description, prediction data set so that we all practice together. So this is about the descriptive statistics, which helps us to be able to just describe our data set in brief without going much into the data. So we want to use the data set to do the practice, at least run some descriptive statistics on the data. And from there, we can take it to another level. So I am going off to share my screen for the prediction data set. All right, please, any question?
No,
Okay.
please.
All right, thank you.
No,
So let me share my screen. Okay, so this is a data set, the prediction data set. So it has some nice information. That is, it has a variable called R&D. It has a variable called administration. Also has a variable called marketing. And then it has a variable called profit. And also there are other variables like EST, that is employee satisfaction 1, employee satisfaction 2, that is the ESTATIS 1, 2, 3, up to 5. So what will you do as someone or as analyst once you have a data set of this sort. So as part of the first option, you need to identify the problem. So here, the business problem for the day could be you want to, let's say, model profits of organization based on variables like R&D, administrative costs, and then the marketing strategy that you have, plus employee satisfaction. Because if you can do research and development for your employees, you can give them, buy the necessary equipment or tools for them at the workplace. You can put in all the strategic mechanism for marketing purposes. And the employees are not satisfied one way or the other. I don't think you'll be able to get your profit because they would not work. So these variables are important in predicting profit of an organization. It can be any form of organization because in every institution or any organization, there is definitely R&D. There is administrative costs. You have to pay rent, you have to pay light, you have to pay for papers, printers break down, you need to buy computers. So all these form part of the administrative cost. And then the marketing strategy could be a cost that you incur through online, let's say, print media advert, radio advert, TV advert, social media, Facebook advert. You incur some costs in posting your information out there and so on. And then the profit that you get at the end. So these variables, one way or the other, can predict what the sales of or the profit of organization will be. So as analysts, what you need to do is you need to scan the data. So once you open the application for the first time, you will see two main views. You have the data view, and then you have that of the variable view. So the data view and then that of the variable view. Now, the variable view helps you to be able to describe all the variables that you have in the study. So in this case, I have a variable like this. So I have described the variable, I have described administration, I have marketing, and so on. So we do all the data description at the variable view. And then you go to the data view to enter the corresponding data for each of the variables. That is how data entering is done using the SPSS. So first, describe your variable. So for instance, if I have a variable like age in addition to what I have, I click on, or let's say I type age, then click on the variable view to take me to the other view of it. And then here I can begin to enter the age. So if I have 20, I have 45, I have 66, I have 39, and so on, then I do everything over there. So you can equally import the data from SPSS, from Excel and bring it to SPSS, or you can type it directly in SPSS. So it all depends on you. So once you describe the variable, so this session is what is called the variable name. So we have the variable name at this session, as you can see written name, and then the type of data that you are going to enter. So R&D, is it a numeric data? Is it what kind of data it is? Now we have several of the data types. So these are the data types. So all that I need to do is to click in any of, let's say, the options here. You have numeric. Just click in this small button. There is a button here. There is a button, just click on it. Once you click, it will give you the various data types. Now you can see the numeric. It means whatever we are going to enter there is a number. You have the comma, you have a dot, you have scientific notation, you have date, you have dollar, you have currency, and so on. So ask yourself, what kind of data are you going to enter in the data set? It is very, very important, because if you choose the wrong data type, you might not be able to run certain tests on the data. So please, let's take note of that. If you want to enter numeric and you then select a string data, string is not a numeric, so the system will not allow you to enter a number there. So please, let's take note as part of the data management process. You need to know the type of data that you want to type over there. Is it a number? If it is a number, you just need to select numeric. If it is not a number that you want to enter there, but you want to enter a string, let's say names of some people, then it will be appropriate you select the string data type. So let's take note of that. And here we have the width. This is the width. So you need to ask yourself the kind of data set that you want to enter there. What is the width of it? But mostly the default is what? Is 8. But if you have a very lengthy word that you want to type over there, then you can go ahead and enter. Then you have the decimals too there. So depending on the nature of the data, if it's more about currency, maybe you are dealing in Ghana cedis and so on, or monetary values. If it is 2 decimal places, you select. If it is 3 decimal places, you just click in the box and the system would allow you to increase or decrease the decimal. So you have increase, you can increase using the up arrow or decrease using the down arrow. Okay, then we have the label. The label that you see over here, the label that you see over here is what describes the variable name. So I have a variable name called R&D expenses, or let's say R&D spending, or expenditure, or whatever. Now you come to this label and describe this R&D that you've written over here. So maybe you can decide to say that expenses on research and developments. You can write it in full. That is what is going to display when you run the test. So you can describe all the variables here. You can describe all of them over here. So that is a way to describe the variable. One good thing about it is if you describe the variables here, or if you give them labels, and then you share this document with someone, the person can easily relate to the data set. But if you don't describe the variable that you have over here, and then you just send the data to the person has to rethink or sometimes ask you for the definition of ESTATIS. You see, so it is all the time very, very important to have a label. And all this side also, it forms part of the data managing or even processing stage. Here, you've not done anything. You just want to put the data in its rightful manner so that when you begin running the test, you will not struggle, you will not be asking yourself, especially when it comes to the interpretation, because you don't know what is ESTATIS is. But if you know what it is, then you'll be able to write appropriately if you need to do so as part of the work. So that is with the label. So the label describes the variable name. So the label that you give at the end of the day is going to describe the variable that you have. So let's all the time try to give a label to our data set. Okay, so we have the values. The value section is usually used to describe, or it's usually used to define the levels of a variable. So for instance, if I have another variable called gender, if I have a variable called gender as part of my data set, we all know gender has two levels, male and that of what, female. So it has male and that of what, female. Instead of me to just leave it like that, type male and female in the data view, I'd rather try to define the levels of the variable called gender at the values. So I click in this box, or I click in this space where it's written none. I click on it, this small dialog box. I click on it, and then define the levels of gender. So I can assign male to 1. So I can say that the value 1 should stand in for male. And then I click on add. Then I enter 2. 2 is for female and also add. Then I click on OK. So for example, if I want to enter the data set for gender, if I want to enter the data set for gender, I go to the data view, and then where I have gender, as you can see, gender, I'll only enter 1, 2, 1, 2 there. So that is how it is done. So I'll just enter 1, 2, 1, 2, 1, 2. So this is how you can define the variable called gender. If you create the levels, or you create using the values to create it, this is how you will do it. So you don't need to be typing male or female and so on. All that you need to do is just type 1, 2, 1, 2, 1, 2. So that is how you can define your variable. Please, do you have any question? Is there any question that you want to find out? Is there something that you want to find out?
No, not yet.
Okay. All right. So, but then I think, hello. Oh, it's okay.
Yeah, I mean, it's fine. The presentation is fine. I was just alerting you to some messages on the platform.
Oh, okay. Messages. Okay. 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 Then let me.
So I don't know if you can
Mess.
go to more. So, sorry.
I have not received any message yet.
On the WhatsApp page.
Oh, okay. 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 Nothing. Okay.
There's one Christiana and then one KJ.
Oh, okay. 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 All right. Okay. All right. Okay. Oh, okay. Let me do that. Okay. Sorry about that. Okay. All right. But please, do you have any issue with the how to describe the variables?
No, I don't have that.
No, no issue now.
Okay. All right. Thank you. Okay. All right. Okay. So let's move on. Okay. Okay. So all these form part of the data cleaning or processing stage. So having been able to now define the variables, one important thing that you need to also take into consideration, the missing and then the columns, the alignment are not all that's necessary. They are not necessary. So what you need to do, you can just ignore them. You can ignore them. It will not add anything to the result. But one thing here that is of essence is the measure. So if you know you are going to do more of quantitative analysis using techniques, then it will be appropriate at all times. Your data should either be a scale data. It should be a scale data. So if your analysis, or let's say if your analysis that you are going to perform is more on these quantitative tools, then I would say that it will be appropriate you change them to a scale data, because the scale data is more numeric and continuous. We also have SPSS has 3 scale of measurement. It has the scale, it has the ordinal, it has the nominal. Unlike we have the main scale of measurement are nominal, ordinal, interval, ratio. But the system combines the interval and then the ratio as scale. So we don't have the ratio as a scale in the application, but we have what is called a scale. We don't have interval, we don't have ratio separately, but here the ratio and then that of the interval are now combined and it is called a scale. And then we have the ordinal and then that of what the nominal. So these are the types of data types that we have, or let's say data measurement types that we have in the application. It is very, very important. Sometimes you want to run a certain kind of analysis, but because you do not select the right measure, the system will not allow you to proceed. So let's take note of that. Okay. So after you've been able to, define your variables, then you have to go to the data view and let's say begin to enter the data. So as I have already done here, once you do that, you just enter the data. You just enter it like that, and then you just move on. So that is how data entering is done in SPSS. For me, I don't like entering data in SPSS direct. So mostly I have to do it in Excel and then try to export it to SPSS. So you can also do that if you want to. You can all the time try and then enter it. If you think the Excel will help you, or the entering it direct in the SPSS will help you, that is fine. So it all depends on what you want to do. Okay. All right. So let's.
I have a quick question.
Yes,
This is
sir.
Sam.
Hello.
Thank you, Mr. Zari. No, I just
Yes,
wanted to
sir.
find out, in the situation where you have you're dealing with ages, since we're on the age column, respondents give you responses that indicate that look, they are between say age 35 to 44 or 40. How do you input that in the data view, for instance?
Okay. All right. Thank you. So for instance, if we have age, so we can create a variable called age group. So where you have the variables in groups. The first one is not in group. That is the raw ages. And I must say that it is all the time appropriate to allow the respondents to provide their age if you want to work or use the variable age to do some further analysis. Because the moment you group the age, sometimes it is difficult The only test that you can perform on could just be a categorical kind of a frequency test analysis and so on. But if you allow them to enter their raw ages, like what we have here, you can even regroup the age by yourself. You can regroup them for further analysis. So you have the raw ages, and at the same time, you have the grouping variables too as well. But let's assume that you have your ages in groups. So let's say 18 to 25, 26 to 30, 31 to something. It's the same as what I did for the gender. So you have the variable called age group, then you come to the values, and then you have to assign, depending on the levels of that particular variable called age group. So if you have it from 18 to, let's say, 18 to 25, 26 to 30, and then 31 to, let's say, 35, then you just enter the value 1, then you go to where the label is. You type 18 to 25, and then you add, then you go to 2, that is 26 to 30, then you click on add, and then you go to 3, that is 31 to 35, and then you add, then you click on OK. So once you get to the data view, all that you need to do is just be entering. So let's say the first respondent is 18, within the age group 18 to 25. So you just enter 1. Let's say the second respondent is within the age group 31 to 35. That is 3. And then let's say the third respondent is between the ages 26 to 30 years. You enter 2. So at the end of the day, you'll be having just 1, 2, 1, 2 live in the case of what? The gender. So that is how it is done. It's the same procedure as I did it for the gender. So maybe you have educational level. Educational level 2 has its own category. So if it is, let's say, none, have you been to school? Maybe as part of the information that you are picking, you are asking, have you been to school? The person says none. So we have none, primary, secondary, tertiary, or whatever it is. So that one too, you need to define it. So you need to define it as I did it for the, let's say, the age group. So 1 is none. Then you go to 2, primary education, 3, secondary education, 4, tertiary education, 5, whatever, depending on the levels that you have for the variable. Please, is it okay?
Yes, it is. Thank you very much.
You are welcome. Okay. All right. So let's move on. Okay. All right. So have you been able to define your variable? For instance, so if you want to know what the 1, 2, 1, 2 is, the 1, 2, 3, 1, 2, 3 is, in the case of, I'm talking in terms of this one, but this is where we defined. No, sorry, I think the first age is not part. So I think it starts from gender, this particular session. So this side. If you want to know what the 1, 2, 1, 2 is and so on, you can come to this side. You go to the view on the menu. You go to view on the menu, and then you select value labels. So you select value labels. So view, and then you select this particular one. That is value labels. So that is what you need to do. Click on view, and then value labels. So this one. So this is what you need to select. So once you click on it, it will show you what the 1, 2, 3 is, and then what the various levels. So as you can see, the system has given us male, female, and then the age classification too as well. So that is how you can, you can use to define the age variable. Now, there is this variable here called employee satisfaction, and it has 5 questions. We want to measure satisfaction of employees using these 5 questions. So let's assume we ask them these 5 questions, and it's based on agree to disagree, or let's say strongly disagree to agree, or to strongly what agree, a 5-point scale. You have designed your own instrument that you've given it to the participant to rate their level of satisfaction at the workplace. So you have this, you have that, you have 5 of them. Now, you can define values and values levels for them. So in the case of, let's say, this particular questions, we are going to define the levels, that is 1 strongly disagree to 5 strongly agree. So it is the same procedure as in the case of the age and then that of the gender. So we come to the value here, and then I type 1, strongly disagree, I type strongly disagree, then 2, disagree, then 3, let's say neutral, and then 4, agree, and then 5, strongly agree. So if this is what you have, depending on where you got your information from, it could be order of importance. Rate this item, very important to less important, and so on. So having been able to do 1, you don't need to come to this place again and do it 1, strongly disagree 2. All that I need to do is just copy the first one. Okay, so the first one, copy the first one, right click and copy. So right click, once you do right click, you see the option. Please just copy. Right click the first option and then copy. So you right click, copy, and then select the rest of what? The variables, right? And then right click and paste. So once you paste, the system will do it for the rest. So you don't need to do it one after the other, especially if you have a lot of items in your model. It will just waste your time. So do for the first item and then copy it and replicate it to the rest. That is all. So now we have been able to, define all the variables and even added 1 variable to it. 1 variable, I think 2, age, gender, and then age group itself. So we want to perform the summary statistics on the data set, or the descriptive statistics on the data set. The descriptive statistics will help you to check so many things. So let's begin with it. Please, any issue with the data definition and entering of the data definition, or describing the data in the application, and how you can also enter it? Any question?
Sorry, you did not explain the ordinal, then the other one.
Okay, the scale, right?
Scale, yes. Ordinal and
Oh,
nominal.
okay, all right. So we have the 4 main scale that I already mentioned. We have the nominal, ordinal, interval, ratio. That is a no. Now, the nominal data, a data set that is nominal is only into category. So a variable like gender is a nominal data, in a sense that there is no special effect between the levels of gender, or within if within 5, but between there's no specific difference. If you're a female, you are not special. If you're a male, you are not all that special. You can't say that females are more important than males. Or can someone say that males are also important than females? So once you just have category, once there is category, just category, it is nominal. Now, if you move from the nominal and then you go to what is called the ordinal, then here you are now adding some kind of effect on the category. So the order here, let's take the ranks of the police or the military, or let's say the security service. You could see somebody will be a recruit, someone becomes or someone is a recruit, now becomes what's the name, sergeant or brigadier or whatever. You realize that if someone is a sergeant, the person is higher than the recruit. So we can't say that we are the same, though we are all police officers. But at the end of the day, the person with the highest rank has, let's say, higher command over the first person. Another level is pain. Let's come into the area of, let's say, sickness or disease. Pain level. Pain level. If there is a device to measure pain level, if someone's pain level is, let's say 30 and yours is 10, here we can see that the person whose condition is around 30 or whose pain level is 30 is highly, let's say, at a certain point that if you don't do something about it, the person can just pass on. So that is why sometimes when you go to the hospital, they will tell you that your condition, you wait, let's attend to someone's condition first. I know we are all sick, or let's say if you are sick, that is why you go to the hospital. But the knowledge of the physician or whoever is looking at you or looking after the patient thinks that someone's condition is more severe as compared to the other. So the moment you add some kind of effect to the categories that you have, male and female, the moment you say that now females are better than males, then it means you have moved from the category to now to what? Order. You are placing more effect on that category that you have made. So that is about the ordinal. And as I said earlier on, the interval and then the ratio. So like our salaries, like our income, the temperature of AC, your weight, my height, all those values are now put together called what? A scale in the application. So basically, these are the three main categories of measurement of data, and we need to know them, what they are. Nominal is just category. Ordinal is by order. You are putting some effect on the categories that you have created. And then the scale is anything numeric in nature. So you can take any measurement, whether you are using a specific device from or within your lab, or you are measuring some people weight, height, body mass index, or whatever. So all those values, or let's say all those variables with numerical assigned to, are all classified under the scale data. Please, is it okay?
Yeah, it's okay. Thank you very much.
You are welcome. All right. Okay, so that is with the different types. So we want to examine the data for if descriptive. So we go to, so please, we will be using the menu analyze a lot. So please, let's take note of that. So we click on analyze. So we click on analyze on the menu, and then we look for descriptive statistics. Now, if you click on analyze and then you select descriptive statistics, it gives you a lot of options. So you have the frequency count, you have the descriptives itself, you have the explore, cross tabulations, and so on. Okay, so I would use the descriptive statistics, then click on frequency, and then we see what is there. Now, let me just explain the difference between the frequency and then the descriptive. The descriptive statistics just summarize the data without giving detailed information. And then the frequency is able to break things down for you. So please, let's take the first, let's do the first one, the frequency count. So we go to analyze descriptive statistics frequency. Okay, let's try to, put in the, okay. Let's try to put in all the 4 variables. That is the R&D, administration, marketing, and profit to the box. So analyze frequency. Let's see the beauty of it. So let's select the first 4 variables and then place them here. So click to select and then move them to this box. Okay, so highlight them and then move them with the arrow. So the moment you move, they will move from this side to this side. Okay, so from here, you can now click on statistics. Please, let's click on statistics. You click on statistics. Now, when you click on statistics, these are the information that you see. You will see the percentiles. You will see the central tendencies. You see the dispersion tools. And then you also see the distribution mode tools. So the question is this: what do you want to do? What are you after? So if you want to know the average, the median, the mode, the sum, and so on, you just select them. If you want to know the minimum, the maximum, you select. If you want to select the skewness for the dispersion, or let's say for the distribution, you select the two to help you to test the normality of the data set. So these are the tools that are available to you. So per the data set that we have data set on expenditure or expenses on research and development. We have that on administration. We have some on marketing. We have some on profit and so on. So we want to find out about the main expenditure on research and development, administration, the marketing strategies, and then the profit that we've made over the period. So we click on the main to ascertain that, and then also check the minimum expenditure for the 3 and then that of the profit. And then we can click on OK. So once you are done with this, you just click on OK. You click on OK. You click on continue, and then you click on OK. So once you do that, this is the results that you get from the frequency. The frequency will give you a lot of information. So the first result that you get is the statistics sort table. This is what you get. Now, after getting this, the system will take the frequency for each item, or let's say each variable. Now you can see how many times the 0 occurred, 2. How many times did this expenditure occur? 5, 4, 2. It will tell you 1.
Hello,
How
please. I
many?
think the results window is not showing.
Oh, okay. Sorry. Okay. All right. So once you click on OK, let me share the. Okay. Once you click on OK, this is the results that you get. This is the results that you get. You will get the summary, or let's say the statistics. The first you will see what you selected, the statistic that you selected. So here you can see the mean, you can see the minimum, you can see the maximum. That is what you selected. So the system will generate such information for you. And then it will give you the frequency count for all the values under that particular variable. So here it is telling you the number of times that 0 occurred in the data. 0 occurred 2 times. How many times did you get 442.1 CDs? also 1,000.2 pesos, and so on. So it will give you all this breakdown one after the other. So that is what the frequency will do. So if you are interested in this, then that is fine, but it is not advisable for a quantitative data like this. You produce a very lengthy frequency count. It is not appropriate, because if you need to present these tables as part of your reports in your research work, then I think you end up getting about, if it is a manuscript that you are writing, you end up getting about 100 pages, which is not appropriate, and no print media or a journal would accept that kind of input from you. So the frequency is not appropriate. It is only appropriate when you have a categorical variable like gender. So a gender variable, or let's say the age grouping. You see, if you have such, this is very small, so you can easily present it in the work, but not for the entire variable, like a numerical variable like what we have. It is not appropriate. So the frequency is not appropriate for this particular variable, but you can use what is called the statistics, because this is what maybe you are after. You want to know the average expenditure on R&D, and then what is the minimum R&D, and now what is that of the maximum R&D, right? And then when it comes to the administration too, you have same statistics for it. So that is the frequency. Now let's go and look at the descriptives itself, what it does. So here we select the descriptives, and then we move the variables in it. So we move them and also click on options. If you click on options, these are the statistics that you see. It also has similar information. It has the mean, it has the sum, it has the standard deviation, it has the minimum, it has the maximum, it has the skewness, and then that of what kurtosis. So here you have to determine what you want. So for example, if you also need minimum, maximum, mean, and then that of standard deviation, you just select and then click on continue. Then you click on OK. So now let's check the results that the descriptive statistics will give us and compare it with that of the frequency count, or let's say frequency analysis. So I click on OK. Good. So if I click on OK, this is what I see, right? So this is the descriptive statistics. This is the descriptive statistics. So as you can see, this is the descriptive statistics. So now it summarized the entire work in brief for me. So I can easily copy this and paste it in my document, as compared to the other one that gives you the breakdown one after the other, right? So if you select the other statistic like the skewness and kurtosis and so on, everything will show over here for you. So this is the difference between the descriptive statistic and then that of the frequency analysis, or let's say the frequency statistics. Okay, please, any question? Do you have question? Okay, so we are good. Okay.
Sorry, no, I wanted to quickly find out. So when or how do you know which statistics will be best for your data? You know, sometimes that's a bit of a struggle. Using the right or appropriate statistics to analyze your data.
Oh, okay. Okay, so it all depends on the type of should I say the type of story that
Your
you want
objective.
to, yes, that you want to tell. Because I don't think I'll be able to suggest the best. I don't think I'll be able to suggest the best descriptive tool that can help you to be able to tell your story. But if you have it in this numerical form, then what you need to do is, because maybe if you are writing an article and you need to prove everything based on, let's say, previous research. For example, you want to talk about normality. That is one of the key assumptions when it comes to most modeling processes. You want to say that the data that you have is normal, so you can go ahead and perform or use this technique for your analysis. Then it means you need to select a particular kind of statistic. That is the skewness and kurtosis. So, for example, if we want to check whether the data that we have, R&D, administration, marketing, and profit, if you really want to check whether they are normal, then after selecting the variable, you click on options, and then you check the skewness and then that of what? The kurtosis. So these two, you need to check the two variables, skewness and then that of what? Kurtosis. The skewness and then that of what? Kurtosis. So you click on the two options. So once you click on the two options, you click on continue and then you click on OK. So now, if you run the test, this is what you see. So there will be additional information for the skewness and then that of the kurtosis. So, sorry, you have the skewness and the kurtosis like this. Good. Now, at what point are you going to, so I'm using this opportunity to explain the normality aspect. At what point will you say that the data is normal? So we are saying that a data is normal if you are using the skewness and kurtosis when you have a skewness value plus or minus 2, and then you have kurtosis value also plus or minus what? Plus or minus what? 2. These are scientific based. You can Google, you can search research work that have been done in the area where they talked about normality. You can check. In other papers will tell you that skewness and kurtosis should take the skewness should take a value plus or minus 2, or the kurtosis should take value plus or minus what? 7. So it is likely you will get an article that suggests that skewness and kurtosis should be plus or minus 2, or skewness should be plus or minus 2 and kurtosis should be plus or minus what? 7. So if you want to talk about normality, you can use these two options. So from the data set that we have, we can see that the absolute values of all these values, what you see here, they are all less than, let's say, plus or minus, or let's say they are less than plus 2, and also within negative what? 2. And this side too, you can also see that we don't have any value above 2. So here we can say that the results that we have, or the data that is coming out from the participants, or let's say from where we had the data, right? They look what? Normal. So expenditure on R&D is normal, administration is normal, marketing strategy is normal, and so on, based on these statistics that we have. Please, is it clear?
No, Mr. Azar, it's not clear. We're saying that the skewness and kurtosis should be within plus or minus 2.
Yes,
So
please.
when they are within plus or minus 2, then it's supposed to be a normal, the data is supposed to be normally distributed. Or is that
Yes,
other way
please.
around?
Yes, please.
Please come clear on that. If it's within plus or minus 2, is it that when you can say that the data is normally distributed?
Yes. So if the data is within plus or minus 2. Within plus or minus 2, then you are talking about normality. That the data is what is normal. Let me just share. Though it is in the, I think hopefully by next week or so. This is okay, so this is a paper, one of my papers. It will come out shortly. It's still under its proof. We are doing the proofreading. It has been accepted, so I can share the information with you. Let me, by next week or two, I'll share the article with you so that you can, now you go online, you won't get it. It's only with me. I'm just doing, I've done with the correction and everything. This is what I'm talking about. So if you can see from here, let me enlarge it a bit. Okay, so there is something here. It says, according to their guidelines, okay, an item is deemed to be normally distributed when its skewness and kurtosis fall within the range of 2.00 to minus 2.00. The results of the analysis indicated that both skewness and kurtosis values were within the acceptable range of -2 to +2, as suggested by this. So this is what one author is saying, that you should get within plus or minus 2, signifying normal univariate distribution. According to this author too, her et al., they also indicated same, that you should get between plus or minus 2. Now, as you can also see from here, according to this author, I said that data is considered normal if skewness fall between -2 to +2 and kurtosis fall between -7 to 7, further supporting the conclusion of normal distribution. So depending on the author that you are making reference, okay, you are making reference to his or her article, you can decide to say that the data is normal based on that person's what information. So this is a way to ascertain normality of what a data set. So you can use the skewness and kurtosis to do that. You can use the other tests. We have the Shapiro test. We have the Kolmogorov test, which will look at it as part of the descriptive analysis. So this is how you can ascertain normality of a data set. And as I said, once the paper is out, I will share the link so that you can download it and read. It has a lot of information that can help, advanced modeling and so on. So you can see here how the results was presented. So you can see the item, the mean, the standard deviation, the skewness, and then that of what the kurtosis with the associated p-values and so on, right? So please, this is how you can, or this is what you can do to now determine normality of a given data set. So let's proceed. Please, any question? Do we have any question?
So from what you are saying, it means that the data we have now is not normally distributed, right? Looking
The
at
data that we
we are
have,
dealing with now.
yes. So from here, you can see the skewness. You can see the skewness and kurtosis. Please, let's look at it carefully. Do we have any value greater than 2 on both sides, skewness and then kurtosis?
No.
So, Mr. Sorry, you need to switch back to your SPSS screen.
Oh, okay. Hey, sorry. Oh, sorry. Okay. All right. So let me. Okay. Okay. All right. So this is the results that we have. So for you to say the data is normally distributed using the skewness and ketosis. So just look at the result that you have. This, sorry. So you have this result here, and then this side too. So just go through and see, is there any value that is greater than 2? We don't have any value greater than 2. We don't have any value greater than 7. So we can say that we are all within the plus or minus what 2 for skewness and then that of ketosis. So we can say that the data that we have is or follows the normal distribution pattern. Please, is it okay?
Yes, please.
Okay. All right. Okay. All right. So that is it for the descriptive. Now let's look at the explore procedure. Remember, we are on the descriptive statistics side. We are still describing our variable. So let's go to the descriptive statistics, the exploratory aspect of the data. So we want to use the explore procedure. So we go to analyze and then descriptive statistics. Then we click on explore. So you can check it. So we have analyze, descriptive statistics, and then explore. So this is what we are going to look at. Descriptive statistics, then you select explore. So what is this explore? This explore is able to give you a lot of information about your study variables or the data set that you have. In fact, it has a lot of functions, and especially you can use it if you have a categorical variable that you want to compare with the rest of what the data. So for example, let's go back to the data set itself. Let's go back to the data set itself. So let me open the data set. So this is the data set that we have. For example, if we want to, let's say, find out if these are all, let's assume that we want to find out if this information that are coming out is dependent on, let's say, the gender of the employees at the workplace, right? We can just find out the statistics for gender against that of, let's say, any of the variables. So let me just populate this information here for gender so that I'll get up to 50 levels so that it will be in line with the other variables. So let me just enter anything 1, 2, 1, 2. Let me just enter to just get 50. I want to just get 50. Okay, so now I have 50 for the gender. I have generated 50 observation for gender. So I'm going to, let's say, explore the gender against, let's say, any of these variables. So for example, as I said, if we want to determine whether it is the female that are giving us more sales, or let's say more, or we are investing more in the females than the males, we can do that. We can just use this procedure to do that. And all these forms part of the descriptive analysis or the descriptive statistics. So we go to analyze on the menu, and then we click on descriptive statistics, and then we click on explore. So let's all do that. Go to analyze descriptive statistics, and then you click on explore. So you click on explore. Now, the moment you click on explore, this is what you see. You see this dialog box that is telling you what is the dependent list, what is the factor list. So this is all that you need. And then you have the statistics too here. You have the plots options and so on. So here, our dependent list is going to be, let's say, all 5 variables, all 4 variables, R&D, administration, marketing to profit. We move them to the dependent list. And now the factor or the categorical variable, we move it to this box. So at the end, we have something like this. All 4 variables, or let's say all 4 variables will come to the dependent list, and then the factor will be at the gender will be at the factor list. Then we click on option statistics. You click on statistics. Here you can decide to select. Let's highlight all of them. Let's select all of them. Once you click on statistics, highlight all of them. Remember, your analysis is in 95% confidence level. So here we leave it as it is. We have 95% confidence level. So we leave it as it is. Then after clicking or selecting the 3 indicators, then you click on continue. Here we have plots. Here we have plots. So let's click on the option plot. If you click on the plot, there are other statistics that you see. You can see the stem and leaf. You can see histogram. So let's select histogram, and then normality test. So you can also select the normality plot with test. So let's select the normality plot with test, and then select histogram, and then click on continue. So I select histogram, I select normality plot with test, and then click on continue. Then click on OK. So now, once you click on OK, let's go and check the results that we get from the output. Let's go and check. So let me go off the screen. Let me go off the screen and then check. Let me share the other screen. Okay, so the system is still running. You can see it's a huge analysis that I've given to, or computation that I've given to the machine. So you can see running, it is running it. So once it's done, I'll see the output. Okay, so it is done. And I believe yours too is done.
It's just that we did not do the age and other things, so we have to just follow you.
Oh, okay, okay,
Some of us did
sorry.
not enter the age and other things.
Oh, okay, 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 okay. Sorry for that. Okay, all right. So, once you run it, this is the results that you get. But please, you can equally enter anything for the gender. Okay, just to be in line. You don't necessarily need to get the same results. So you can just enter any data for the gender 1 2 1 2 or something 1 1 1 1 2 2 2, so that you can get and then run and get something. So once you click on it, it gives you the
Hello, Mr. Sir.
hello.
I just joined. Does it mean that you are using 2 computers?
No, I'm using one computer.
You are expecting us to do something. I'm just watching you. I don't know. I just joined, so I don't know. You are asking them to do something, and I'm just watching what you are doing. So I don't know whether.
Oh, okay. So what I'm doing is like whatever I do, one way or the other, I expect you to also do it at your end, because I've shared the data set with all the participants. But you can watch it and then later practice it. It's also a one way. If you can follow it, I do you also click, then I think that is perfect. Or you can just watch the screen, make your notes, and then you can go back, because the recordings will also be made available to you. You can play it and watch it later and practice.
Okay. Thank you.
You're welcome. Okay, so we have the case processing summary. which gives us information about, it gives us the gender distribution per the variables, So you have male, for example, we have 23 for males, 27 for female in terms of profit, and it's applicable to all the other variables. Now, this is one of the important table that you get if you use the explore procedure. Now you can see from here that the system has given you two main section against a variable, that is male and female. So you can see here male and then that of female statistic based on the expenditure on, let's say, R&D. So it is giving you the estimated expenditure for males to be this, and then that of female to be this. So if you are doing a comparative analysis, male and female, who is giving us more profits? Male and female, who is giving us more this? You can just use the explore to just get an overview about the data set. So here you have the mean, you have the, let's say, the median, you have the median, you have the variance, you have the standard deviation, you have the minimum, you have the maximum for just male. The same way, if you go to the female too, there are other information applicable to that particular variable against what gender. So this statistic or this procedure, the explore procedure, has a lot of information that you can make good use of. If you are even writing an article and you have to do something like this, do a comparative analysis or so, you can use this procedure to explore it. All right. So that is for, let's say, R&D. We have it for all the, so the system will compute it for all the variables. So you can see R&D, administration, marketing, profits. Let's just look at profits for male and female. You can see the profit for male. The profit for male is almost 116,380. And then the females are giving us 108,291. So here we can say that males, let's say participants or employees, are giving us more, let's say, profits as compared with that of what their female counterpart. So this is it with the various statistics. You can see the skewness and kurtosis too. So within the male, the values that are coming out, is it skewed? Is it normally distributed? So you can see that within the males, the values that are coming out is normally distributed. Let's check it for the female. The females too, this is their statistic for the skewness and kurtosis, is also normally distributed based on the cutoff values plus or minus 2. So this procedure is good. It helps you to get more insight. So it's like you can use it. If you want more statistics, you can just use it and get more information. All right. So you have, this is what I was talking about. It's of essence to me. Good. So we have the normality test. So this is the test of normality. You want to find out if R&D, administration, marketing, profit for the various variable levels, or let's say gender levels, shows statistically what significant. So here you see you have the main variables here, and then you have the gender as what? As a variable with its what? Levels. Then you have the statistic for each. So here the system has computed the statistics for each level for gender against the variable itself. So you have the test statistic here. You have the statistic. for the Kolmogorov. So here we have two types of normality tests. The first test is the Kolmogorov-Smirnov test. This is the Kolmogorov test for normality is here. And then we have what is called the Shapiro test. The Shapiro test. Now, the difference between the two, they are all tests of normality. But the Kolmogorov-Smirnov test, it's appropriate if you have a larger sample or if the sample size is large. That is large data size. And then the Shapiro test is appropriate when you have at least 30 observations in your data set. So if you have 30 observations, maybe 30 participants form part of the study, or you took sample on just 30, right? The Shapiro test is more appropriate because it was designed to take limited observation. The Kolmogorov test is appropriate when you have larger sample size, right? When you have larger sample size. Okay, so let's take note of that. The Shapiro can just handle, not just handle even thousand. It is meant for small. So if you are doing a comparative kind of samples, and you have, let's say, 10,000 as against 30, it will not be appropriate to use the Kolmogorov test for the 30, right? But rather use the Shapiro test for the 30 observation and use the Kolmogorov test for the 10,000 or 5,000 or 500 observation. That is what has been designed for. But the fact that we are saying that it can accommodate or it's appropriate for smaller sample size like 30, that doesn't mean that you can't use it even if you have 500 observation. You can still go ahead. But the theory behind it is that it should be used for smaller samples. So if your small sample size is 500, then it will be appropriate to use the Shapiro test and then use the Kolmogorov test for a larger observation. Now, you have the results for the Kolmogorov and then that of the Shapiro. How do you know whether the result is normal or it is not normal? So you need to state or formulate a hypothesis or formulate a hypothesis to say that the data is normal or the data is not normal. Remember, in my article, I do not go through the Kolmogorov or the Shapiro test. I use the skewness and kurtosis to do that. So if you want to use the Shapiro or the Kolmogorov test, then you should focus on the test statistic here and then that of what the significant what values. So here you can see that the significant or the p-values, the p-values are all greater than 0.05. So once you have significant values greater than 0.05, then you are talking about normality. You are talking about what? Normality. Yeah. Hello. Is it okay? So
Yes, we are following.
good. And if it is less than 0.05, you are talking about insignificant or the data is not what normal. So hypothesis for the null hypothesis for normality is that the data is normal as against the data is not normal. So once the P or the significant value is greater than 0.05, then you can say that the data is normal. So from what we see, you can see that all the significant values are greater than 0.05. So we can say that there is normality for all the variables at their various gender levels. Please, any question? Right. All right. Okay. Please, any question? So let's say hypothesis. I type now. Let me just go off again and let's say state the hypothesis. So let's say I come to this place and say, let's say null hypothesis. If you want to, this is more academic. So data is normal, and then the alternative hypothesis, I say that data is not normal. Data is not normal. So here, once you get a significant value, once you have a significant value, that
Hello,
is,
you said you are going off, but you are still here. Oh, the
hey,
screen.
please, can you see the test of normality table?
Yes, please.
Yes,
That is
yes.
what you are
So
using.
yes, so I think that is where I am. So I think that is fine. Okay. So once you have the hypothesis, that is data is normal, and then data is not normal, you just go to your table and check. You just need to go to the table and check. So if the P is greater than 0. If it is greater than 0.05, then you are talking about normality. Then if the P is less than 0.05, then you are talking about not what? Normal or non-normal data. So not what? Normal. So these are the things that you should know. So from here, you just check. You can see that all the values that you have are greater than 0.05, because the first one is 0.200, which is greater than 0.05. And then for the Kolmogorov, if you check the Shapiro test tool, the first value here is 0.345 for the males. So here you can say that the result that is coming out from the male is also normal, female is normal, and it's applicable to all the levels for the rest of the variables. Please, any question? Are we okay?
No. Yes.
Please, are we okay?
Yes, we're good.
Okay. Please, let's get it. So if there is some doubt, please let's clear it before. I don't want us to go home with a lot of questions in our mind. So if there is something you don't get it, please kindly let me know. Okay, so that is where test of normality. That is the test of normality. So all these are additional information that you get if you use the explore procedure. It gives you the diagram representation of the data against male and female. So if you need it as part of your report, you can add them to read. So this is more on the descriptive statistics session, the descriptive statistics session using the descriptive tool in the application. So we have looked at all these descriptive statistics in detail, and I think we have to move to the inferential. But before we come to, there's something I did not look at, and I want us to go back to the data. Let's go back to the data and see how best we will be able to analyze it also. So what about these questions? These questions that has a level, satisfaction, which has 5 levels, or let's say 5 questions under it. Satisfaction has 5 questions. Okay, remember, we cannot measure, you can't just ask someone a simple question like, are you satisfied, to get the overall impression about satisfaction. It is not appropriate. It is not appropriate. So usually what you do is you if you want to measure satisfaction, you measure satisfaction based on set of what items. Okay, if you want to measure my satisfaction level at the workplace, you don't just meet me and ask, are you satisfied with this institution? If I say yes, what happens? If I say no, what happens? So you need to be able to ask so many questions, and research has shown that at least you should ask two or more. So you need to ask 2 or more questions to determine someone's satisfaction level. So those of us in, let's say, if you're in social science, you'll be doing a lot of this, some of these things, modeling here and there. You want to measure motivation, you need to ask so many questions. You want to measure satisfaction, you need to ask so many questions. Training and development, you need to ask so many questions, and so on. So this is a typical example that we have, and we need to be able to, run some descriptive statistics on the 5 items too, and then see how it looks like. And also try to even composite, or let's say create a composite value for all 5 items, so that you will get what is called satisfaction as one variable. So that is what we are going to look at. So let's run the descriptive statistics on the data. So here we go to the analyze descriptive statistics, and also go to descriptive. If you want to select, let's select the frequency. The frequency will give
You
you
are
a
not
lot of.
sharing your screen.
Oh, okay, sorry. Let me share the screen once again. Okay, so this is the data. So I go to analyze descriptive statistics and select descriptives. Then I select variables of interest from ESTATIS1 down to the 5, and then move them to the box. So here I can select the statistics, the options. Maybe I am interested in all this. So I select them and then click on continue. Then click on OK. So now I can check the results. Let me share the results. So this is the results that I get. So I have this. I have the mean, the maximum, the mean, the standard deviation, skewness, and kurtosis. And these statistics, if you are using a Likert scale, it is very, very important to report on the skewness and kurtosis as part of the work, especially if you are doing a higher degree research work, let's say a PhD or a master's, whatever degree, and you are writing your thesis or even writing a manuscript and all this kind of thing. It is advisable you put out some of this information in the way. So you have all this. So you can present on the standard deviation, you can present on the skewness, you can present on that of the kurtosis, and even the mean. Okay, so these statistics are key as part of the analysis that you perform in that, or using the descriptive for such variables, like this, measuring what is called, let's say, satisfaction. So satisfaction measured using 5 items, right? So you can equally run all this as I have already done, summary statistics on it, so that you get to know the mean score that they give. So this particular item On average, they scored it 4.06. So here you can see that they are more at the agree side than the disagree side, because we said 1 is strongly disagree, 2 is disagree, 3 is neutral, 4 is agree, and then 5 is strongly agree. And we have a scale of a value of 4.06. That shows that they agree. One or the other, it's within the strongly what agree. Though we don't have 5, but it's still what a high agreement what value. So this, you can do this to also explore, or let's say to explain the levels that you have under satisfaction. So here we are saying that satisfaction is measured using this what 5 levels of what items. Okay, so I have 5 items here, and I want to composite or put all these 5 items together as one. You see, because sometimes we don't have the skill to be able to do a higher modeling when it comes to statistics. We end up compositing the items. That is good. You can composite all of them as one and call it satisfaction. It is good. But sometimes you also lose a lot of information. So there are analyses that we perform, like the exploratory and then that of confirmatory analysis, which it is one of our next topic, or let's say our next training that we'll be running. Solely for, we are looking at lecturers, we are looking at PhD students, looking at master students, or let's say independent researchers. They are, or they do complex analysis, or those who are writing articles and so on. So it will be coming on 2nd to 5th of next month. Yes, at ATU. This one is going to be face to face. So those of you who have time, you can come around. It's face to face. It's not going to be online, face to face, so that we have time. It's a 4-day training. So if you composite the data, you end up losing a lot of information. But because maybe you don't have the skill, you end up putting everything together. That is okay. And well, it's accepted. It's accepted. Okay, so how do you composite all these 5 items as one? It's a very simple procedure. So on the menu, the SPSS menu, you have the transform. You can see transform. Okay, so you look for the transform on the menu. It is there, and then you click on it. So let's click on it. Once you click on it, you will see option here that is known as compute variable. That is the calculator aspect of the application. That is the calculator aspect of the application. So let's click on it. Once you click, it gives you this output. You get this option here. So here you can see the target variable. You can see all the variables that you have in it. So this is the target variable. This is the target variable. All the variables that you have will show here. You have the expression environment. You have the calculation numerical values or symbols there. And you also have what other functions that you can use depending on what you want to do. So we use this approach to have one variable called satisfaction. So we give it a target name. So the target name is satisfaction. So you can type satisfaction. You type satisfaction. After typing it, meaning that is a new name that you want to assign to the calculations that you want to perform. Then you come to the numerical expression. You come to the numerical expression. This is where you write the expression to compute or to do the task that you want to undertake. So here, how do we do that? We do that because we want to composite, we find the average of what the data. So we just type average, or let's say you type mean. So let's type mean. You type mean, then you bring the open bracket. Then you select the variables that you want to a composite, and then you introduce what? Comma, one after the other. So I select the first variable, then introduce a comma, second variable, introduce a comma, the third variable, a comma, the fourth comma, and then the fifth variable, comma, and then close the bracket. So at the end, this is what I have. So I have the target variable name as satisfaction. If there is something wrong with the satisfaction, if it is a reserved word, if it is a word that is embedded in the application, the system will not allow me to run it. It will tell me that I have used illegal word or variable name. If there is something wrong with the function here too, the system will not allow me. So this is what I have. So I have the variable name called satisfaction. Then I have the function here. Then I introduce the first level of that variable here. It is ESTATIS1. Then I introduce a comma. Then introduce the next variable, a comma, third comma, fourth comma, and then the last one. Then I close the bracket, then click on OK. So if everything is okay, the system should give me or return something to me. So I click on OK. So once I click on OK, the system says that it has executed the command. So now you can see the system has executed it for me. Now somebody will ask, so where is the composite what variable and then the data associated with it? So we need to go back to the data set. So let's go back to the data set. So let me stop sharing the output now. So let's go to the data set itself. So I go to the data set. Now go and look for the new variable. So you can see the new variable here as satisfaction. This is the satisfaction what variable. Then where is the corresponding data? Then I go to the data view. So I click on the data view, look for satisfaction at the extreme end. So now you can see satisfaction here as what? One variable. So now the system has generated one variable called satisfaction for me, and I can use it for further analysis instead of the individual items like this. 1, 2, 3, 4, and then 5. Now I have one variable called what? Satisfaction. So this is how you can create composite variable in SPSS. Please, any question?
I was just wondering, Mr. Zari, so the compositing of variables, what are the limitations? I fear sometimes compositing might lead to you losing some kind of insights with the other subcomponents. What do you say about that? Or am I wrong
Yes,
to?
yes. So as I indicated, when you composite, it's like you have lost track on all the other, let's say, levels. So it's like you are not dealing with the individual items anymore, but you are only focusing on just one. So that is why it is advisable to run summary statistics on all. So as part of the kind of work that you are doing, if it is, let's say, a long research work, or let's say if it is a manuscript, you can try as much as possible to run summary statistics on all the variables rather than the composite one. But if you want to use the composite variable, let's say the satisfaction to run a test like, let's say, regression. Maybe you have satisfaction with, let's say, 5 levels. You have motivation with 5 levels, and you want to regress motivation on satisfaction. Right here, If you are not using a robust tool like the confirmatory techniques, which I said we'll be looking at next month, then the only option that you have is to composite. Because with the confirmatory is, it enables you to, have all the other items that you have. It enables you to put all of them together. You don't need to composite anything. All that you need to do is include all of them in it. So a typical example is this. Let me just show you one. So this is a typical example. This is a typical example of the confirmatory, the complex modeling, which I said we'll be looking at next year, next week, next month, second. So now you can see here that all the items under, let's say, a particular, let's say, construct, you can see all of them here. So if it is about satisfaction, you will see all the items under satisfaction, and then you will see the variable called satisfaction what here. Okay, so you will see the variable called the construct called satisfaction with all these what items. But if you don't have the know-how, you will not be able to do it. And here, you need to report on the contribution of each item in the model. So if you don't know how to use it, then you end up just compositing it to just get one variable, right? So let's take note of that. And one, it also depends on what you want to do. It also depends on what you want to do. If you are not into much complex modeling, then you can just composite it and get one variable like this. But if you want to go to that extent, the confirmatory aspect of your data set, then you can go there and have each item accounting significantly in the model. Please, is it okay?
Yes, fantastic. Thank you.
All right, thank you. Good. So let's move to the next session. Let's move to the next session. Where is my screen? Okay. So we are moving to the inferential analysis. So we are moving to the inferential analysis. So basic introduction to inferential statistics. So the inferentials, so please, we are done with the descriptives. I hope we are okay with the descriptives.
Yes, please.
Yeah, very good.
Okay, thank you. All right. So we are going to the inferential statistics. So the inferential statistics are what we use if you want to take evidence, or if you want to take, or you want to do concrete, or you want to have concrete evidence about the data. The descriptive will just describe the data in brief without giving you much insight. But the inferential statistics is more appropriate if you want to, make some kind of, take some evidence-based decision, not just the minimum is this, the maximum is that, the mean is this, and so on. But here you want to make an informed decision. And if you want to make an informed decision, the tools that we use are not descriptives, but rather we use the inferential tools. Anytime you hear of statistics is not about the descriptives, it's about the inferential tools. But they are the tools that we use for concrete decision making. So there are a lot of them. We cannot go through all of them. There are so many. And I don't even know them all. I can't even know them too. So the few ones that are available or procedures, we need to know them, and then we can build upon the ones that we already know. So we have the hypothesis testing as one of the inferential. Anytime somebody is talking about hypothesis testing, then it means the person is more into the inferential statistics than the descriptive. And then we are talking about the confidence intervals. Once you are setting a confidence interval, I am 95% confident that my data will fall within this range or it will be within this. It is more inferential than descriptive. Then we have the regression analysis. That is one of the most powerful techniques when it comes to predictive tools. And then we have the analysis of variance. The analysis of variance, it enables us to explore differences in means for at least two or more independent variables or two or more dependent variables on a categorical variable. And then we have the chi-square test. The chi-square test is a test that enables us to examine association that exists between categorical variable, categorical against nominal variable, categorical against interval variable, which I believe strongly that we will go through all this technique one after the other. All right. So that is, hey, am I sharing my screen?
Now you are not, but you were before.
Oh, okay. Okay. So, okay, sorry. So that is it. Okay. So, okay. So these are the tools. So, we have data processing. So data processing, which I have already looked at, but because it's more inferential, I decided to also bring it here. So you need to take time to go into the data. You need to take time to go through the data to ensure that the data is screened well before you proceed. Okay, here, when it comes to data processing stages, there is something we call data processing stages when it comes to inferential analysis. And these are the stages that, or these are some of the things that you should look out for, especially when it comes to inferential analysis. So the first option or the first thing that you need to look out for is missing data. Go through the data set and find out, do you have any missing record? Do you have any missing record in the data set? It can affect the results that you have. So go through the data set. Do you have any missing? It is very, very important. It can cause your results. It might even create, or it can inflate or deflate the results that you have. You can also deceive your audience, or because you do not take into consideration missing values. So it is very, very important at all times to look out for missing values as part of you running, let's say, inferential analysis. Some of the tests, if you have missing, the system will tell you that it cannot run with what? Missing, especially if you are running exploratory or confirmatory analysis. The training that we'll be organizing next 2 weeks, if there's missing value in it, the system will not even convert. It will not run. It will tell you to check for the missing values in the data set before you even proceed. So missing will not allow you to proceed with some of the techniques. But of late, the versions that we use, for example, the SPSS version, the latest version version 27. What I share with you is 27. So those using 27, they have included some procedures in it that even if there is missing, you can still ask the system to override the missing and then proceed and give you something. And there are some missing procedure approach that you can instruct the system to even delete and maintain the actual values in the model and proceed. So, but please don't assume that it will be appropriate at all times. Clean your data first. Ensure that you fill all potholes within your data before you go ahead. The system is not programmed to be all that intelligence to determine what you want to do. So check for all those in the data set. Then we have what is called the outliers. Now, these outliers are some strange values that you have in our data set. So look out for them. So if you are considering a data set for, let's say, children below 10 years, you are saying the study is about children below 10 years. Let's say you are not including, or if you are including 10, greater or equals or less or equals to 10, then meaning you should get 10. Someone should be 9 years, someone should be 5 years, someone should be 4 years, somebody should be 3, somebody should be 1, somebody should be 7. The moment you have something like, let's say, 30 in it, this value that you see becomes what? An outlier. And this value can affect the results that you get. Outliers are very, very dangerous. They can make your data look what? Better, thinking that everything is okay, but they will end up causing problem for you. So let's take note of that. The moment you calculate the average of this data set, this data, the average is likely to be above 10 or so. And you are going to do presentation to some professors or do presentation to some, maybe there's a conference that you are attending and your study scope is for children less than 10 years. Maybe you are looking at a health condition among children less than 10 years. And then you come out to say that the average age of the data set is, let's say, 12.5. They will even laugh at you. They will ask you, how come? You said your study is for children less than 10 years. How can you have what? Average of 12.5? You see, you put yourself in a very serious situation. And at that point, I don't think people will take it serious anymore. So please, outliers are very, very important. All the time, look out for them. The simple thing that you can do is you can run frequency on it. Look for the minimum value, look for the maximum value. If the maximum value is 30 and you know that 30 is not supposed to be part, maybe the person who did the data entry was entering 3, but end up adding 0 to it. So now it became what, 30. Quickly go back to the data and check. That is one of the easiest way that you can use to what? Check for some of these things. It is very, very important. Let's take note of that. It is very, very important. It can cause you, it can make you, like in quotes, you don't know what you are about, and so on. So please, let's take note of that. Another technique or another thing that you need to look out for is the normality, which I have already looked at when it comes to the inferential statistics. That one, I have talked much about it. Then we have what is called the linearity. Please, linearity is very, very important. You are conducting a study that looks at employees' performance at the workplace. That is the study focus. You are talking about factors that influence student, let's say, employees' performance. Look out for variables that relate closely with employees' performance. Do not go and look for a variable that has nothing to do with the dependent variable. If you do that, you are not going to have that linearity that we are talking about, because it will not be able to relate well. If you just use, let's say, a scatter diagram to establish the relationship, because the variable has nothing to do with the dependent variable, it will end up it giving you a curve relationship. But we are talking about a linear relationship. It means that variable that you are using has something to do with the other variable. So let's take note of it. Linearity is very, very important. It is very, very important. So all the time, if you are embarking on a study, just consult literature. Let literature give you all the variables of interest so that you can fall on them for your study. As to how you can even design your instrument, literature should be able to give you all those things so that you don't have a dislinearity among what the outcome variable and the variable itself. Now there's something called the homoscedasticity. The homoscedasticity is one of the assumptions, or it's one of the things if you want to perform inferential analysis in, let's say performing inferential analysis. Like let's say you want to perform what's the name? A regression analysis, blah blah blah, and so on. They are all there to help you. What is it all about? It's all about this constant variance that exists within what the data set. So at the end of the day, you want to ascertain whether there is a constant variation that exists within what the data set. Once you are not having constant variation in the responses that are coming out, then there is what issue, especially if you want to do a predictive or if you want to do predictive analysis and the data that you have is not, or there's variation in the data, you realize that you will not be able to get good results. And we said that a good result or a good data is that data that has what constant variance across. Not that the first you have a data set like somebody getting let's say 45, then another person is having 120, let's say 200, and then another person is having 5, another person is having 450, another person is having 56, and so on. The moment you run, you realize that the variation in terms of one data level from the other will be too wide. So we are not after a data that has what various, or let's say varying what variances, but rather we want what constant what variation. The data set that you have should have what consistency, or should follow that kind of what consistency. So here, let's say if it is 40, the next person is having 32, the next person is having 45, the next person is having 50, and so on. So you see that there is constant variation in terms of the result, not one having a value that is extremely higher than the other variables, or let's say the other values. So that is homoscedasticity. It is a very important assumption. Now we have what is called the collinearity. Collinearity is one of the assumptions that helps us to determine the independency of our variables. So if you want to check whether the variables that you have in the model are independent, then you can pass it through the collinearity diagnosis. So that at the end of the day, you will get to know whether the independent variables are indeed independent. So for example, if you are saying that let's say motivation, you are saying that, let's say motivation, satisfaction can influence, let's say, performance at the workplace. So these two variables must be independent. If they are not independent, right, they cannot influence this variable properly. If let's say motivation depends on satisfaction before performance can occur, then these variables are not independent, but rather they are dependent on their own. And we don't want variables in the model to be dependent and against the dependent variable. You don't see the beauty or the contribution of the variables in the model. It's like you employing some people to work in your company and the employees are not independent. They cannot take initiative by themselves. You get, so the question is, why did I even employ 5 people? Because if Kofi wants to take a decision, he has to go and see Ama. If Ama wants to take a decision, he has to go and see Isaac. If Isaac wants to take a decision, he has to go and see this person. It means the employees are not independent. It's like they can't take initiative. They depend on another person. I am not saying that don't go, like the employee should not go and ask somebody if he or she doesn't know about something. But we are talking about, you see, sometimes you go for a job interview, they ask you, what are you bringing on board? That is the independency aspect. What are you bringing on board if we employ you? Meaning you should be someone that you can take initiative. So it's like you can take initiative with less supervision. If someone is not there, you can do something. That is the independency that you are talking about. So if the two variables depends on each other, then it will be appropriate to just take one of them out. So when it comes to modeling and you realize that the variables are dependent, you need to take one of the independent out, because if all the time you need to go and see A, B, C to act, then why don't I do away with the other people so that I can just focus on 2 people to work on the project for me? So that is about the independency of variable using the collinearity through what is called the variance inflation factor. When we start with regression, we will look into it and see how best we can test for some of these things. Please, any question?
Yeah, hello.
Hello.
Yes, Mr. Asare,
Yes,
just
sir.
a quick clarification. With
Okay.
regards to the outliers,
Okay.
the example you gave was more or less like it is, let's say if you are using ages, and then you said if the ages that you are looking at is between 1 to 10, and then probably you have a 30-year-old into it, that's an outlier. But my question is, let's say, even though I'm looking between maybe age 1 to 20, and then from looking at my data, I realized that most of the responses that or the responded or the data that I have looks like they are between, let's say, 15 years to 20 years. And there is maybe one person who is 1 year. So look at a chunk of the respondents are between the ages of 15 to 20. And then there's one person or two who are very less, let's say 1 year. Even though they are between the same age range that I'm looking at, should I also consider that as an outlier?
Yes. So once the data is at one side, you realize that from 15 with just one variable or one of the levels with a value like 1 or 2. Yeah, it means that that's 1 or 2 that you see becomes what outlier. It's like it is far from the rest of what the data points. So it can still be within 1 to 10, but you realize that you have majority around, let's say 7, 8, 9, 10, with just 2, you have just 2, 1, and then 1 occurring as part of it. So such values will also be classified as what? Outlier when it comes to the modeling process. So it is not only you having that extreme value occurring, but looking at the sequence of the flow of the data, if you realize there is only one that has just set aside somewhere, and then the rest are also skewed to other session, we term that small value as also what? Outlier. Yeah.
Okay, that's fine.
Yes. Okay. Please, any other question? Okay. All right. So let's begin with the first inferential test. That is one way, one sample t-test. If there's no question, then we start with the one-way test. If there's no question, then we start with that. Okay. All right. Now, what is the one-way, what am I saying? One sample t-test. One sample t-test. What is this test? So one sample, or what is the t-test what test used for? So the t-test, they are the t-tests. We have three of them. We have the one sample t-test. We have the two sample paired test, and then we have two sample independent test. And they are used to analyze limited or small data sets. That is at least less than or equals to 30. If the observation is less or equals to 30, you can use the t-test family to analyze it. It is a test between two variables. So let's take note of that. It is a test for two variables. So if you have more than two variables, the t-test is not appropriate for that. If you have more than two variables, the t-test is not appropriate for that. Okay, so a test like the one sample t-test is used when you have a sample data as against, let's say, a parameter value. Okay, so let me come again. So at times you have the data set. So let's say you have taken the body mass index of a group of people. So you've taken their body mass index based on their weight and height of a group of people. And then you want to make a hypothetical statement by saying that the body mass index of, let's say, a student in a typical university is, let's say, let's just get some value. Let's say if it is 20, let's assume it is 20. Let's assume if it is 20, I don't know whether 20 will be appropriate under the body mass terrain. So you make, if that example is not appropriate, let's say age. So we can make a hypothetical statement by saying that the average age of a student, a first year student at the university level, is equals to, let's say, 19 years. 19 years. So we can make this hypothetical statement by saying that the average age of a university, a fresh student at any typical university is what? 19 years. Then we need to, once we have made that hypothetical statement, we need to be able to go out there and collect data on ages. So let's say we enter into a typical university And then we begin to look out for the first years. Then we gather data on them. So the first student that we met, he said he's 20 years. The second person says, I am 19 years. The second person says, I am 18. The second person says, I am 29. The second person says, I am 22. The second person, I say, and so on. So you've been able to gather this data on, let's say, about, let's say, 30, or let's say a lot of them. It can be even in hundreds or thousands or whatever. So you want to check this hypothetical statement that you have made, that the average age of a typical first year student at the university level against the actual ages that you went out. You are the researcher. So you have to go out there to go and solicit for information. You don't need to listen to what people are saying, that the average age of a student at the university is 100 Ghana. Hey, why am I saying, why all this? It's what? Let's say 19 years, right? There's a data set in it. So it's what? 19 years. You need to go out there, gather information on the student about their age, and then you check it against the hypothetical statement. That is all about the one sample t-test. That is what it does. That is what it does. So you can also pick a certain variable. That's the average income of, let's say, a typical work, let's say, employee at the formal sector is let's say 2,500. So this is what a hypothetical statement. So you just make this statement by saying that the average income or income is equals to 2,500. Then you go out there and go and solicit for information from the employees. So you can go to the ministries, ask them how much do you earn, provided they will give you the actual values. This person will tell you, I earn 3,000, I earn 2,000, I earn 5,000, I earn 6,000, I earn this. Now you compute, or you compare the hypothetical value with the actual data set that you gathered. You can use it for so many analysis depending on your study area. So all that you need is to get a hypothetical value and then go out there and go and gather data and then use it for your story. That is all. That is all. So let's look into it. Let's look into it. So we said that it's a test. It tests whether there is difference in means between the population from which your sample data are drawn and a hypothetical population. So this is the sample. So as you can see, this is the sample as what? A known value. There is a value that you are comparing it with. So this is this person's age. This is the age. This is the age. This is the age. Then the result, a hypothetical value that you have to be, let's say, 25 or 30 or so. Then you compare it with it. That is about the one sample t-test that we talk about. Please, any question before we go into the data set? Okay, so if there is no question, then let's look at this. Let's look at this example. Says the data name one sample t-test refers to student academic performance in 3 courses, namely read, maths, and social studies. A teacher a teacher claimed that the average score of the student were all above 45 in the 3 courses. Verify this using the sample of 20 students. So the data set that I shared with you, let's use that data set, the data set called one sample t-test. So let's look for the data set called one sample t-test, and then let's practice with it. I believe we all have the data set.
You have it too, but can we the same computer?
Okay, all right, no problem. Okay, okay, that's fine. So let me do it. So the one sample, okay, t-test. So this is the data set. Let me share my screen. So this is the one sample data set. It is data set on reading, maths, and social science, or let's say social studies. So we want to compare the score that the student obtained from what the teacher indicated that the average score that the student obtained is equals to 45. So this is the data set. So you have reading, you have maths, and then social studies. So let's find out, how do we perform this test? Remember, as part of the data processing, you need to look out for normality. You can, as I said, you can look for normality. You can check for other things in the data set. So it's assumed that you have done all those. So then let's go and perform the t-test using the one sample t-test. Okay, so we go to analyze on the menu, then we go to compare means. So analyze on the menu, then you select compare means. So analyze, then you come to compare means, then you look out for one sample t-test. This is it. So one sample t-test. So analyze, compare means one sample t-test. Okay, so analyze, compare means one sample t-test. So this is the interface that you get. So you have the one sample t-test showing up there. Then all the variables in the study, you also see them here. And then you have the text box. So this is where you need to move the variables of what? Interest. This is where you need to move the variables of what? Interest, okay, to the box. And then you can click on the options if you want. You click on the options to see what is there. Okay, so let's select the variables. So let's select all three variables and then move them to the box. And then remember, there was what? A hypothetical value of 45. So this is where you position that 45. So you position the 45 in this box. You place it over here. Okay. So you just enter 45. If you click on the options, this is under missing. As I indicated that the system has introduced other ways of dealing with what? Missing. Exclude cases, analysis by analysis. So if you don't want the system to exclude, or let's say to include the missing, if there is missing, the system will not include it as part of the analysis. So as I said, this the modern versions, they have introduced more procedures to make life what easier. Okay, so you click on, you enter the test statistic value. Here we have the effect size. The effect size helps us to know the extent of the gap between the estimated and then that of, let's say, the hypothetical, the estimate that you obtain or from the actual results, and then that of what the hypothetical, or the difference between the hypothetical value and then that of what the test what value. Okay, and according to Cohen, he has grouped the effect size into three. That is, we have small effect, we have large, medium effect,
Sorry,
and
I
then
don't know. Hello, sorry. I don't know
yes,
if it's
sir.
my screen that is not displaying your text box, but your text box is, however, is some way like small in a way. On the one sample t-test dialog box.
Is it this one?
No, this one is clear, but the one that when you're doing the analysis, we can't see the whole. Anyway, I can't see the whole field. I just see the big
I
box
think it's the
that you
same
have to
for me.
enter the thing. Others, I don't know whether it's the same for the others.
No, I can also see. Yeah.
You can
You
also
you
see.
can
So
you can't see.
Yeah, we see
so
your
you have to
screen, but
expand your
the dialog box, the one
for
sample
the
text
analysis.
box, you know, the part where the confidence interval percentage pops up and all of that. We can see it on your screen, your shared screen, but we see like half of it is cut away.
Hey,
I don't
wow.
know. I don't know if it's the
Okay,
internet connection or whatever.
okay. Let me reshare it. Okay. Okay, please, is it showing now? Can you see this one? Is it better?
Yes.
Yeah, it's showing now. Yeah.
Yes, now it's better.
Okay, all right, thank you. All right, so after this, then you just click on okay, you just click on okay, then you check the results. So let me go off and then share the results. Let me go off and then share the output. So at the end, you get this results. You get this results. So the system gives you summary statistics on the variables. So now you can see it has the estimated mean value for the courses. So we have 3 courses: reading, mathematics, and social science, with their estimated what values in terms of mean. But remember, the hypothetical value was 45. So the system is now going to compare this hypothetical value of 45 as against the values that you collected from the field. But here we are getting a mean of 40, 54, 52, and so on. Yes, this is more descriptive in nature. Please, if you should use this value to conclude, you will be wrong, because this is descriptive. The result that you see here is descriptive. It is not statistical. So it could happen that the 45 and then the 54, there is no significant difference. Remember, anytime you hear of significant difference, then we want to have a very wide gap between what the two variables. So maybe 45 and then 54, there is no significant difference. Or 45 and 52 is not significant. Or 45 and 54 too, there is no significant. So please don't use these values to just conclude by saying that because the value is 45 for the hypothetical value, and after the data collection, you had the value of 54, it means the hypothetical value is significantly different from that of the actual values on the ground. This is more of descriptive. It will deceive you. So let's zoom into the statistical aspect and see if indeed there is significant difference between the hypothetical value and then that of the sampled what data. Okay, so if you want to know that, you use the second table. So the first table is more on the descriptive. The second table is more statistical. So this is where you can talk about significant difference. So now you can see the test statistic what value showing here to be 45. Now you have the test statistic here. You have the degrees of freedom here. You have your significant what values also here. So the test statistic that we have, the test statistic here, the test statistic, that is the T. And take note, when T is greater or equals to 2, it shows what? Significance. Is greater than 2, it shows it equals what? Significance or significant. So anytime the T, the absolute value of the T is greater than 2, okay, is greater, the absolute is greater than 2, it shows what? Significant. So here you can see that the T statistic is greater than 2, which is 4.257, 4.618, 4.17, 4.707. They are all greater than 2. So here we can talk about what? Significance here. But that is just by the way. Let's go to, we have the degrees of freedom. That is the number of observation minus 1. That gives you the degrees of freedom. Then the significant. So you can decide to use the significant and then the T statistic for your decision. So the significant value here, if it is also, so if the significant is less than 0.05, then we are talking about significance. If the significant is greater than 0.05, then we are saying it is not what? Significant. So let's take note. Significant less than 0.05, that is, in other words, if your significant or the p-value is greater than 0.05, then we are saying that there is what? Significant what? Relationship or difference. And then if the significant value is greater than 0.05, then we are saying that there is no what? Significance. So here we can see the test statistic and then the significant value all showing some level of what? Significance. So we can say here, based on the data, that there is a significant difference between the hypothetical value and that of the sampled what? Data for reading. So the hypothetical value is 45, but the sample value for the reading is 54. So then we can see that there is a significant difference between the two. Now, this is the difference that exists between the hypothetical value and then the test value. Here, after doing it, we had a difference of 0.984. That is 45 minus the 54 the value over there is giving you 9.85. If you take the maths 2, the difference between it is 7.45. If you take social science, the estimated is 54.8. Hypothetical value is 45. The difference is 9.8. So this clearly tells you that there is what? A significant difference between the hypothetical value that the person gave and then that of the values. It means the students were not getting the 45, but rather they were getting values outside 45. That is higher than what? 45, as the teacher claimed. So this is the effect size. The effect size also. So you can see over here. Here we use the point estimate for the effect size if you want to establish the effect size, and this is according to Cohen. So Cohen, he gave out this definition. He gave out this definition. So here we can see we had a value that is closer that is higher than 0. Where is, can I get, I think I should have, let me check, let me get you one of my slides. I think I have it in it so that, let me see if I can get it. Okay. Effect size, please, just a minute. Okay. All right. Please, is it showing? I just want to show this one of my training slide. Please, is it showing?
Sure.
Yeah.
Okay. Okay.
Yes.
Okay. So Kohan, he is saying this. So you can see the effect size. He gave values from 0, 0.01 is small effect. And then if you get 0.06 is medium effect. And then 0.14 means a large effect. So this is according to Cohen 1998. He gave this recommendation to judge effect size. So let's take note of that. Let's take note of that. Maybe you are doing some before and after test, before the intervention came in, and then after the intervention, what is the effect that that system has or maybe have on the, let's say if it is about participants, you can use this effect size to calculate whether it had the intervention that you gave to the people, whether it had what large impact or medium impact or small impact. It is very, very important. It's applicable in most research in medicine, health, let's say health related what research. They use it a lot. When it comes to social science too, they also use it a lot, especially if they give some intervention to a group of people in a given area. They want to examine how that intervention maybe have on the participant. So it is very, very important to know the effect size of the kind of support that you give or intervention that you give. All right, so this is the results. So from here, I think we have close to large impact, or let's say large effect, because of the values that we are getting over here. So you can add all this as part of your report. You can add all this, but it will not be appropriate in terms of you reporting. You can't report all the results that you have from the output. So at least you can have just one table, and then the rest of the information will just come below. The effect size, we use the eta. So depending on, here is the Cohen, but other authors too, they have their own way of reporting it. So that is how you can report. Just add the point value. For example, if it is this one, you just write it as additional note just below the table Cohen test for effect size. Or there is a symbol that you have. Sometimes it's like this. It looks, if you can't write a symbol, it's like that. And then you can write equals to, then you type the value over there. That shows effect size. Or you can write effect size. If you can't write a symbol, just write effect size and put equals to value there. And then I think that is fine. So based on this, you can conclude by saying that there is significant difference between the hypothetical values and the scores that the student or were obtaining, and the difference that exists between the hypothetical value and then that of the sample data is large based on the Cohen estimate for effect what size. So this is the one way, one sample T test. Please, any question? Okay, so because because of I think we are supposed to end at 8 o'clock and it is 7:57. So I think we need to end here. God willing, tomorrow we will finish. We would finish the rest of the test because now you understand the basis, you understand the various basic things. So once we come, once we do a recap for just 5 minutes, then we zoom into the other tests so that we can finish on time. I'm believing strongly that we should be able to finish all the things that we've outlined. The one sample is already gone. So God willing, we will look into the paired sample. We'll look into the paired sample. That is the independent sample. And then we'll look into the paired sample. Then we'll do some correlation analysis to interpretation. And then we'll look at simple to multiple linear regression. And then we look at one way. I know it entails, but we will finish. And then reliability. If we can join on time, we'll be able to finish all this. Because one of it is because we have already looked at some of the assumptions, we don't need to look at the other assumptions under, let's say, the paired sample. So right after the output, we just do the interpretation and then we can finish everything on time too. Please, any question? Do you have any question with respect to the things that we have looked at for today before we bring today's lesson to a close?
I have no question. I've really enjoyed it.
Okay, thank you. All right, thank you. So the recording, we'll keep the recording and God willing, tomorrow we would continue from where we got to at the same time, 5 o'clock. Then we start 8. We should finish. So thank you very much.
Mr. Sari,
Hello.
so the recording, where is it? Will you give it to
Ye-
us or?
Yes, I'll share it. I'll share a link with you so that you can download it.
Okay. Okay.
Uh-huh.
Thank you.
I wish you would convert it into this. You share the YouTube link rather, because mostly the teams, when you share, I think I've engaged in a couple of trainings of yours. The teams, when you share, downloading it becomes a challenge. So maybe probably this time around. Yeah.
Oh, okay. So I'll rather put it in my drive because we are using a facility, let's say account. So it's like if you are not within the domain, you're unable to access it. So we've realized that we need to download it and keep it in our drive so that we give you the drive link so that you can download it. That one, it will not require you to log in, or better still, we can also upload it in our YouTube channel so that you can also pick it from there. So we will work on it for you.
Okay. Okay.
We will
Or
do.
Telegram. Or Telegram. You can share it on Telegram for us.
Okay. Okay, that's fine. That's fine. Okay. All right. Thank you.
Thank you too. Enjoy your
All
evening.
right. Okay, same to you. Bye bye.
Bye.